Good morning, everyone. This is Carl Griffith from Graybar, and I want to thank you for joining our G2 Talk webinar today. I'm the Director of Emerging Technologies at Graybar, and cellular coverage or mobility is one of those areas that is part of the emerging technology category here at Graybar. So I'm very excited about putting on this G2 Talk webinar today. Before we get started, there's a couple of things that I would want to bring to your attention. Number one is the purpose of this call. We believe that there's a need for people to understand what the process is, or what is the day in the life of a DAS project from the very beginning when a building owner or building operator determines that they need some help with cellular coverage inside their building for their employees or for their customers. Then what's that process from the time we decide that we need to do something till we get all the way to the end. So this is the purpose of this, is to set up a day in the life kind of conversation about how to improve cellular service inside buildings. Before we bring on our presenters, I would like to talk a little bit about what Graybar's mission statement is. Graybar, the distributor Graybars, our purpose in life here is to help our customers power, network, and secure their facilities with speed, intelligence, and efficiency. And that's exactly what we're doing today. We're talking to facilities owners, building managers about their facilities and how can we improve their network with speed, intelligence, and efficiency. And today, of course, we're talking about the cellular network in particular, or RF or radio networks inside your building. Before we bring on the presenters, I wanted to give us a little bit of information that will help us navigate through the day. Number one is that there's a Q&A associated with this, and if you look at the bottom of your screen, you'll see a little Q&A button. If you hit that Q&A button, a dialog box will open, and you'll be able to type your question in there. Those questions are all recorded, and at the end of the presentation, we'll go through some of those questions. If we don't get to all the questions, we will respond to you via an email. I'm anticipating more questions than we'll be able to cover during this time, but we will get back to you and answer your questions via email. The second thing is that the first 50 people that log in and stay with us through this presentation will receive a gift from Graybar. So we'll send you an email that you can exchange for a cup of coffee at a local coffee store, probably in your area, a national brand, and then you'll be able to exchange that for a cup of coffee. So you first 50 people that joined on, thank you very much. We're glad to have you on here and enjoy a cup of coffee on Graybar. Everything that we do today on this webinar, the recording as well as the presentation, will be archived on graybar.com. So if you go to graybar.com and you click on the G2 Talk logo, there's an archive there. And in that archive, you'll get a PDF of this presentation. And you'll also be able to re-listen to or share this information that you get today with a colleague or somebody else. So we're glad to archive that, and you can go up and look at the archive and see some of the other things we've done, but this one in particular will be archived so you can look at it again if you choose to do so. So our presenters today are two. The first one is Eric Toenjes. Eric Toenjes is a business development manager here at Graybar. He's responsible for the mobility category from a business development perspective at Graybar. That would include both Wi-Fi and cellular type connectivity. Today, of course, our discussion is primarily revolving around cellular connectivity. So we're glad to have Eric with us, and he'll be our first presenter. After Eric speaks, we're going to bring Rick Baldasarre on from Vision Technologies. Vision Technologies is an RF integrator in the marketplace out there, one of many RF integrators that exist. Rick has a similar function to Eric as a mobility solutions architect, the senior mobility solutions architect in the business development and managing projects. We're very, very glad to have Rick on board. Rick kind of represents the onboard in the building kind of process. What's going to happen once an integrator is selected and an integrator ends up on a job, what's really going to happen? Eric's going to give us some information about the planning, the pre-planning to get a project started. So without taking up anybody else's time, I'm going to pass the baton over to Eric Toenjes from Graybar. Eric, thank you very much for joining us today.
Great. Thank you, Carl. Appreciate it, and appreciate everyone's time and attention on the call today. Hopefully we have some good content and something you can learn here. So what I like to start with is getting everybody on some common ground and make sure everybody knows exactly what it is that we're talking about. So DAS stands for Distributed Antenna System, and it's essentially a network of cable and fiber and some antennas with head-end electronics and wireless RF sources, or radio frequency sources. So that is the signal source that pushes into the system and then is distributed over those antennas. More importantly, what it does is it enables wireless technologies in your building, on a campus, both indoor and outdoor. So if you see iDAS or ODAS, that's indoor DAS and outdoor DAS, or you could have a hybrid of the two over a campus. It is enabled then to propagate signal from the cellular wireless service providers like AT&T, Verizon, Sprint, T-Mobile, et cetera, and bring that very strong signal into your building. It can also be used to bring in public safety first responder radios so that they will work inside of the building, as well as your own local two-way radio system that might be used for operations and communications. That can all go through the same system. It also enables in-building 911 calls to be able to be made. It's a key part of any mass notification system that delivers over text messages. And as we look forward at things that are coming, you'll hear the term Internet of Things, or IoT, which really refers to the many multitude of connected devices that are proliferating today. And having a great wireless network helps to enable that transition. So I want to show you really quick just a layout of what a DAS looks like. You can have multiple different signal sources that go into that. So if you see on the left side of the diagram, a cell tower, that's one of your primary signal sources. So you have that signal coming over the air, going into a donor antenna on the roof, and then feeding down into a repeater in this case that would amplify, repeat, and filter that signal. You could also have a direct source from the carrier. So you see my blue box there from the carrier switch over a T1 into the head end of that DAS, and in that case you would be using a base station, which is the same electronics you'd have at the base of a cell tower. There's also things called a enterprise femtocell that essentially uses internet backhaul. It all connects into the system. So your DAS then is going to again filter, amplify that signal, use fiber in the vertical, and then a short horizontal out to an IDF, where you take that light signal now, because it changed over from RF to light through that DAS head end, and we're going to take that light signal, change it back over to RF, go out over runs of coaxial cable in your most typical type of DAS, out to antennas spread throughout the building to deliver that signal. So that's really what a DAS is about. We're going to talk more importantly here, though, about what it does for you and how to build your business case. So what I like to do is go over real quickly kind of the evolution that's been happening in the wireless market, because it's been a very high change environment. So if you look in the not too distant past, cellular was a convenience item, and it was primarily used outdoors. As a result, if there was a problem with the cell signal inside of a building, that IT manager would typically say, hey, go to the carrier, let them fix their problem. And those carriers were very much in reactive mode, trying to solve a problem for their customer. The main goal in that case was to improve the coverage inside the building, and really just for that individual carrier. It was typically managed by the telecom manager. IT really was, if you asked IT about wireless, their main concern was about Wi-Fi, but not cellular or DAS. So it was really an outsourced service to the carrier for the most part. Starting about 5 years ago, though, things started to dramatically change to where we are today, where cell phones have become business or even mission-critical communications. They've moved from just being used outdoors to really proliferating indoors. And with the large number of people on there, the goal of the system, while coverage is still important, it's much more about the capacity on the network to handle the multitude of users and applications. We've also moved into a world where having a single carrier system in your building is just not adequate. So a multi-carrier or even a multi-service DAS, adding things like public safety, is really more the norm now. As a result of it being multiple carrier type of solutions, they're much more led and owned by the end user than outsourcing it to the carrier. That means that the IT manager, now looking at that as a critical IT system, is going to manage and want to own and control that system. If you look at where the carriers are at today, they're primarily focused on large public venues where they can get a lot of capacity offload, and we'll talk more about that. So I got a couple of quick graphics here we won't spend a lot of time on, but I want you to get a better feel for what's happened and why we've moved from coverage to capacity. So if you look back just maybe around 2009 and before, the chore for the carrier engineer was to deal with big, wide, spread out places that had sparsely populated number of people that are actually utilizing the devices or the amount of capacity they were drawing from, which is represented by this lightly populated beach. If you look at where we're at today, we've got a very, very crowded environment with lots of people packed tightly, all utilizing things that require a lot of bandwidth. And so, again, represented by the very crowded beach here, you can see that this is a very different challenge than it was just a few years ago. So what is it exactly that's driving all this evolution? And we touched on a little bit of this, but we'll talk a little more deeply here. So if you look at what's happened, the networks originally were designed to operate outdoors. And today, 70% of all cell calls, and I've seen estimates as high as 80%, either originate or terminate indoors. So that outdoor system that it was designed to be is now primarily an indoor system. So that's really dramatically changed things. You also have the expectations of the end user, whether that be an employee or a customer or a vendor partner or whoever it is that's visiting your facility. The expectations that they have for that network is that it's going to work everywhere they go. This has also now become a very big recruiting and retention issue, and you could apply this to a university campus, to a hospital, to a corporation. To recruit the best customers or the best employees, you've got to have a great wireless network, or really networks, because we can talk about both Wi-Fi and cellular, and to really be able to recruit the best talent or recruit the best customers, and then ultimately to retain them, it's important to have a very strong wireless network in your building. Very quickly, we're going to find that organizations that don't address this need start to fall behind, and they're less competitive in the marketplace. If you've seen the term BYOD, that's bring your own device, it really, what that refers to is the end user within your organization being able to make the determination of what type of device, what carrier, and really they're bringing an average of 3.5 devices per person today to your network. And they're making the determination of what that device and which carrier it's going to be, which drives you towards a multi-carrier system. It's no longer good enough, again, to have a system that just handles 1 or even 2 carriers. You've got to be able to let everyone utilize their wireless devices in your facility. So that's really driven, again, the need to control and own that system and not outsource it to somebody else. If you look at the penetration, I mentioned to you 3.5 devices per user. Our market penetration is well over 100%. In fact, I guess that's about 350% when you look at the number of connected devices, and this is going to continue to gain steam and explode. We've also moved away from just a purely voice world into a data world. Everybody's using their favorite data applications on their smartphone. We're starting to push lots of pictures and video, and all this stuff is very bandwidth intensive. We've moved to 4th generation or 4G wireless networks, and we're only a few years away from moving to 5G, which you may not have heard about before, but that's going to be the next round of innovation in the wireless cellular space. And so what's happened is that capacity has become very strained, both on Wi-Fi and cellular networks, as this explosion of data use has gone by. I've seen estimates as much as 16 times of the current data that we're passing over these networks in just the next 2 years. So by 2016, we're going to have 16 times the traffic that we see today. If you're already out there in an organization desperately trying to keep up with the traffic, imagine what you've got to plan for and do in order to handle a 16-fold increase in what's going by today over your network. There's also some energy savings that's gone on. And so I mentioned low-E glass because many organizations have, when they're doing renovations or certainly new construction, they're putting low-E glass on their buildings in order to reflect the sun's energy and keep that out of the building. Well, while that saves you energy costs, it knocks down your cellular signal, it knocks down public safety signal, any kind of wireless service gets reflected off of that glass just the same way as the sun's energy is reflected off that glass. So you can count on, if you've got low E glass in your building or you're about to put it in there, you may move from having coverage to not having coverage in your building as a result of that glass. So it's something to be aware of and understand that you're going to need a DAS in your building in order to overcome that. There's also a number of public safety requirements, and I'll talk about this in a little bit more depth here shortly. But there are requirements out there in national codes for public safety first responder coverage inside of buildings. They are selectively enforced in different municipalities, but the codes are national and they're in place, and it's something to be very well aware of. And again, that's driving the need to own and operate your own system. So I do want to talk to you very specifically. You say, well, what does all these public safety business drivers have to do about my cell phone? So I think you'll start to understand that as we go through this. So first of all, and I've got another slide in here, not to talk about so much, but just as a reference slide for you when you go back and you pull down this presentation, that you can look at the specific codes. But the NFPA, the National Fire Protection Association, and the International Code Council have national codes that tell you inside of a building you need to either validate that you've got good first responder radio coverage, or that you put in a system, which would be a DAS, in order to enhance that signal and make sure that first responders, when they come into your building to bail you out of whatever situation that you're in, that they're able to communicate effectively and be able to respond in the fastest and most effective way. Another driver around this, though, is that, and I already gave you the statistic on the last slide, that 70% of all cell calls are now made indoors. Well, guess what? 70% of all 911 calls are also made on cell phones. So if you look at those combined, and it's impossible to mathematically do that, but there is a high percentage of 911 calls that are made both on cell phones and indoors. And so it's important that we enable those to be handled quickly and effectively inside your building, and we do that again through a DAS enabling those cell phones. It's also important to understand that when you make a cell phone call outdoors to 911, they can see your location through the GPS that's on your device. When you move inside a building, you lose that GPS, and now the public safety answering points, so it's those 911 operators, the PSAP, they're not able to see a location any more than which sector of a cell site you're in. So it's essentially, in most cases, 1/3 of the area that a single cell site covers. That's how much they can see. So they really don't know where you are. The FCC is also considering rules right now that may get implemented as soon as 5 years from now that will require more accurate indoor location information. So your X and Y coordinates, that's your lat and long, plus your Z coordinate, that's your vertical height, may become requirements to provide that information. I'm going to try to move a little bit more swiftly here, but so emergency notification systems rely very heavily on text messages. So if you've got a mass notification system and you're relying on text messages as a primary form of delivery, and you don't have cellular signal in parts of your building, that's going to not work when you most need it. It's also important to understand that first responders, they use cell phones today in order to make calls in an emergency while they're responding to your incident, maybe to call a hospital or what have you. They're also using data applications that are using cellular cards. So again, it's not just their radios. It's also the cell phones and their cellular connection that becomes important in their response. And finally, the way I like to look at all of this is there's a risk management issue. In order to reduce the potential legal liability of first responders and the people you're trying to communicate in an emergency, not being able to complete that could end in a lawsuit. And the cost of a DAS, of course, is a heck of a lot less than the cost of a lawsuit. So something to keep in mind there. As I mentioned, I've got some specifics here on the NFP and NIACC codes. I'm not going to go through this. This will be a good reference slide for you later on. All right, so you get through all these business drivers, and I find many organizations haven't managed to deploy a DAS yet. So why is that? So first of all, the big thing is people still have this idea that it's the carrier's responsibility. Well, understand that they can't control what happens. They can't control whether or not you put low E glass on your building or not. So they don't have control over the coverage inside your building. People are starting to look at cellular service as the next utility. In addition to your water and your gas and electricity, that wireless signal now is a utility, meaning that they can provide their signal to the DMARC, and it's your responsibility to put in your building. Funding confusion is another big piece of this. In other words, you go out there and you figure out why you want to do it, you got your budget in line, and then somebody told you that somebody else got it for free, so you're going to spend a lot of time trying to chase down that free DAS. And this goes into a little bit longer consultative type of conversation that we would have with you, but there's a lot of reasons why the strings that are attached to a free DAS may not be in your best interest. So it's really important to go through what your drivers are, what your requirements are when deploying a system, and understand whether or not you should own and deploy it or allow somebody else to do it who's going to control a lot of the factors. Also determining who you should buy from. There's a lot of different players in the market. They've got a lot of different business models. Some are carrier approved, some aren't. We've kind of already talked about the first responder coverage, but I certainly hear people say, well, I'm not required to do it in my municipality, so I don't know that I need to do it right now. Well, again, look at the fact that you've got national codes in place and the legal liability that might go along with that. Just because you weren't forced to deploy it doesn't mean that you shouldn't. And then really determining which manufacturer. There's a lot of different manufacturers of DAS equipment with lots of different capabilities, and understanding those better can be a time-consuming part of the process. All of these things slow down your deployment. So got one major point here that we're going to go through, and then we're going to hand off to Rick. I want you to understand how the money's getting spent around DAS today, so that free DAS that you're hearing about. So carriers primarily are investing in single carrier systems directly with the customer in exchange for a long-term unit or revenue commitment. So they'll have you commit a certain number of devices to them in exchange for them deploying a DAS in your building. And understand that in the BYOD world that we live in today, you may not be able to make that commitment, and so chasing that carrier investment that happens in that direct way and getting a single carrier system may not be in your best interest. More often than not, we can go to the carrier to get their RF source, so that repeater or base station, and have them provide that, and essentially get into that demarc point while you pay for and own your own DAS. We also have organizations called a neutral host or a third-party operator, and effectively what they are doing is consolidating carrier funding from multiple carriers and deploying a multi-carrier DAS on your premise. They do that, so they will put that upfront capital investment in the system, sign a long-term lease with you, and then sign long-term leases with the carriers to participate in the system. The main places this is going to work, though, are large venues with lots of people on them, and effectively, if you remember my slide about the very crowded beach, what they're trying to do is find ways to offload capacity off of their outdoor network. So even on a university campus with lots of people on it, you may have only a few facilities that really are going to have interest of this type of model, and you've got to look at all the other academic buildings and dorms and so forth are not as tightly packed with people and not as much surge capacity that goes there. They may not be interesting for this particular model. So you've got to be able to weigh those options. Finally, you're going to look, of course, at your own end user funding and look at capital budgets. At Graybar, we've got a great lease program. You can go up to a 5-year lease on a system and use that as a way to pull that project forward while your funding comes in over the next few years. Graybar can also help you out with some contracts we own with the major GPO organizations, through U.S. communities, through our GSA schedule. And ultimately, you may be using a hybrid of some carrier funding, even some third-party operator funding, your own funding, a lease, what have you. It's all the art of putting all those different factors together. Ultimately, though, when you embark on a DAS project, it's a matter of balancing the control you have over the project and that you need over that project versus bringing in somebody else's free dollars, their funding. And so those factors are the timeline that it gets deployed on, the scope of the project, which carriers are attached to it, or do I have public safety on it, and then the choice of this technology. The more that you bring in someone else's outside funding, the more they make the decisions on those factors versus you. So you've got to be able to weigh that. So finally, when you look at the overall process, what Graybar does for our customers is we bring together the contractors that we have relationships with, the public safety agencies and the carriers, the original equipment manufacturers. We can help you weed through those choices. We can bring that neutral host, if that's the appropriate business model for you, to help you with your project. And we bring system integrators as well. We've got a great list of different system integrators across the country that are qualified operations that we can bring to you. And then we apply Graybar's logistics platform to that whole process to make sure that you have a successful project. What I want to leave you with here, though, is that don't be thinking that you're going to finish a DAS project in 30 days. Most DAS projects take at least 6 months, if not a year, and sometimes more, depending on what the approach is that you have for it. So understand that it's not a short process, and there's a lot involved. So I'm going to turn over the presentation now to Rick Baldasarre from Vision, who's one of our integrator partners, and he's going to talk to you about that process and what it takes to go through that. So Rick, it's all yours.
Thank you, Eric. Thank you, everybody, for showing up today and listening to our webinar. So my portion of the webinar is going to be focused on what does it take to have a successful DAS deployment in your facility. So there are several steps that really need to take place to ensure that the system is up and running properly. So one of the first things that has to be done is really understanding what the customer requirements are. Any good system needs to be designed around the valid and concerns of the customer. One of the other issues that are becoming more prevalent with public safety, as Eric mentioned, is with new and or renovated buildings. A lot of the local jurisdictions are requiring public safety signals work inside the building before they'll issue your certificate of occupancy. So any good system needs to take into account the needs that are currently in place by the customer, as well as future needs. If the system is going to be expanded, being able to handle the future technologies, as Eric mentioned, 5G is coming down in a few years. So you want to make sure the system will not only serve your needs today, but be expandable in the future. So, as in understanding the customer requirements, a site survey is used to understand the building and being able to understand what the cable pathways can be for the building. Can we put equipment in certain locations? Understanding what kind of propagation characteristics are of the building. Are there cinder block walls, dry walls? Where the elevators and the stairwells located all come into play in understanding the building and how to design the proper system to overcome the different RF barriers within the building. Another key factor that you need to know is what the ambient RF environment is within the building. So for commercial carriers, when we design a DAS, you need to make sure that users inside the building utilize the in-building DAS and they don't connect to the cell tower that may be radiating in through the windows. A lot of venues have aesthetic concerns to make sure that the antennas do not become obtrusive. So you take all the customer requirements, the building requirements, and the issues of the building, and you put that together and you start defining what the design will look like. So there are several types of DAS solutions out there. There's active solutions which require equipment to be strategically located throughout the building in both the equipment room and telecommunication rooms. For smaller facilities, a passive DAS may be the most appropriate implementation. A lot of times when we're dealing with public safety and dealing with some of the public safety requirements, you may want to end up having two systems, one for the commercial carriers for cell phones and tablets, and one dedicated for public safety and two-way radio solutions. Understanding the building environments allows us to properly create a design, and one of the features that we use is RF link budgets. And we need to make sure that the system will work properly, and because the DAS utilizes FCC licensed frequencies through the carriers, carrier approvals are required for any commercial DAS that's going to be installed. And so some of the design elements, as we talked about, is making sure that there's a defined scope of work for the project. So are we designing the system to meet the needs and the requirements? Having to understand the pricing and the budgeting model for the customer, understanding the project schedule. How long is it going to take to do the job? We'll end up defining a staffing plan. So all the elements are important to get a successful installation. And once we have the design done and you move to the installation process, you have the infrastructure piece of it, all the cabling that has to be installed. So while they say it's a wireless system, there's a lot of wires that actually go in the background to have your wireless system. And so understanding who's doing what within the installation team. Is this going to be a turnkey solution by one integrator, or are there going to be several people involved in the process? Vision has the ability to do it both ways, where we can do turnkey solutions, but we also have a lot of customers that have low voltage providers that they prefer to use. And so having a defined responsibility matrix is critical for a smooth and system operation. And on top of that is having project management, having the communication taking place between the installation teams, between the customer, between the carriers is all very critical for an on-time and on-budget installation. The installation has to be coordinated so that materials and people arrive at the same time, and that equipment can be installed where it needs in a timely manner. So there's not a lot of wait time waiting for racks to be installed or plywood to be installed or cables to be run. As I've mentioned, the cellular cell phones use licensed frequency, so the carriers must be involved. We need to get carrier approval and, more importantly, legal agreements between the DAS owner, the building owner, and the different carriers to legally retransmit their licensed frequency. What happens if this is not done? If the system is causing problems, the carriers have every right to come into the building and actually turn the system off. So you can essentially have a DAS solution installed in your building, but if it's not done right, it can be turned off and becomes unusable. So very critical to have carriers involved in all of these building installations. So some of the things that take place with the carrier coordination is we have to submit, we the integrators have to submit to the carriers design documents, bill of materials, link budgets for their technical approval. These documents have to be done in very specific and required formats for them to do their proper technical design and approvals. And again, without the technical approval, you'll never get the legal approval as well. So it's very critical to coordinate with the carriers, both with the design as well as with the signal source activation onto the DAS. So the signal source is kind of the point of presence between the building and the carrier. And the signal source is, as Eric mentioned earlier, either the repeater, the base station, the E-femtocell, and that connects into the DAS, and we have to coordinate the activation activities to make sure that that goes smoothly. And then the final thing that the carriers want to have is proper as-built documentation, and we'll talk about that a little bit more in another slide. So as the system is being installed, there's going to be testing throughout the entire process. So after the cables are run, we'll do testing on the cables to make sure that they are installed properly, that there's no kinks or overly tight bends within the cables, to ensure that there's not noise generated unduly within the system, which is commonly referred to as PIM. If there's optical cable being installed, we need to make sure that the optical cables are installed and terminated properly as well. The DAS equipment has to be, both rack-mounted, wall-mounted, has to be configured. And then after the equipment is configured and connected to the cabling, we'll do a continuous wave RF testing. And this is preliminary testing done on the entire system to ensure it is working before the carriers come on board and activate their signal source. So carriers, are busy folks. They need to come in, test the system, and it's not appropriate to have them waiting for the integrator to do testing of the system. So a good integrator will make sure the system is up and running and operational before the carriers come in to do their activation with the signal source. Once the signal source is activated onto the system, then we'll do any necessary optimization and fine-tuning, and then most importantly, we'll do a system verification or survey to ensure that the proper coverage requirements are met within the system. All this testing and verification requires specialized tools and expertise. It is not something that can be done by anybody. It is a specialization that is done by relatively few integrators out there. So you want to make sure that folks that you use have the relationships with the carriers and understand the requirements and the tools that are needed to have the system installed and tested properly. I've referenced as-built documents before. The as-built documentation really is your blueprint and manual of the DAS solution that was installed. This is very critical for doing system upgrades, doing system troubleshooting. You have to understand how the system was built so you could troubleshoot it, upgrade it, modify it into the future as needed. After the system's installed, there's also the follow-on warranty and maintenance work. So you have a big investment in the system. You want to make sure that it is always running at optimal performance. And so having a maintenance program in place to ensure the system is operating properly for the long term is an important thing to consider. With that, I'll turn the presentation over to Carl so we can have some time for your questions.
Thank you very much, Rick. Great information. Thanks, Eric, for giving us this overview of a DAS or a distributed antenna system in a building. We appreciate that. Again, the Q&A box is open there. You guys can you all can type your questions in there. We'll respond to them. Eric's been responding to some of them as we've been going through the presentation, and you'll be getting them in the dialog box. The ones we don't get to, we will respond via email later. I have a couple questions. I think I'm going to direct this first one to Rick. You mentioned in your presentation about ambient RF, and you were talking a little bit about the contribution, so to speak, from the carrier's cell site and then what's going on in the building. And in layman's terms, can you help us understand why the indoor DAS needs to overpower, so to speak, the outdoor DAS or the carrier's DAS or the carrier's cellular network? And to what degree is that? I mean, is it a whole lot of overpower or is it just a little bit of overpower? Can you describe that just a little bit in layman's terms?
Certainly. So the issue becomes, as you've been in buildings where you're able to use your cell phone within a building, but you may not be able to use it throughout the entire building. If you install a DAS, you want the cell phones that connect to the in-building system and in technical terms, that's in 6 to 8 dB greater. And all that means is that the in-building signal is stronger than the signal coming in from the outdoors. Why is that important? It's important because you want to have your cell phone communicating to the correct cell tower, whether that cell tower is in the building or not in the building. If your cell phone doesn't have a good connection to the carrier network, to that cell tower, your cell phone will try to bounce or switch between towers because both towers are at about the same strength. And what happens is you drop calls, you get garbled calls, you have slower data transfer rates because your cell phone doesn't have a clear, strong signal to one cell tower. Again, that cell tower being the in-building DAS or that cell tower being one of the multiple cell towers that are out in the outdoor network.
Great, thank you. And I have another question, Rick, that I'd like to ask you, and it has to do with the carrier approval process. In this carrier approval process where your design or an integrator's design needs to be approved by the carrier, I have two questions. Number one, does that require that document that you give to the carrier that describes your design, does that have to be submitted by an RF engineer? That would be number one. And number two, does the building owner get a copy of this approval that was made by the carrier saying it's okay to go ahead and redistribute or retransmit the carrier signal inside that commercial building?
Okay, so typically, I tell you that anybody could submit the design package to the carrier. However, it's going to be an RF engineer who understands how to do a proper design that's going to be submitted to the carrier. So while anybody can submit something to the carriers are expecting these submittals in a certain format utilizing certain tools. One common tool is the IBWave software. And if the package doesn't include the design based upon an IBWave design or IBWave usage, they may not even look at it. So having an RF engineer utilizing the proper tools, creating the proper formatted document is going to give you the best likelihood of the carrier looking at it and acting upon that request. Now, can that document be given to the building owner or DAS owner as well as to the carrier? And the answer is absolutely yes. A lot of times, it's technically related, and the DAS owner, building owner, their concern is, I want to get a DAS in, I want to make it work. Don't necessarily bog me down with the technical details. So a lot of times, I don't give the document to the building owner because it's a carrier approval process, but it is not something that I hide from the building owner. They can certainly have it if they want it, so that's not an issue. The end result of the technical approval process from the carrier is that the carrier moves towards the legal agreement process, which is that agreement that allows the building owner, the venue owner, to retransmit that licensed frequency. And you're only going to get that legal agreement after the technical approvals are in place. So the technical approval process has passed muster if we're able to move into the legal process.
Great, thank you. I know that sitting beside me is Eric, and he's been going through these questions that have been coming in online meticulously, so I'm going to turn it over to Eric a little bit. Are there a couple questions that came in that might be of interest to the entire population that we want to bring out loud?
Yeah, absolutely. Thanks, Carl. So one of the questions that I got here is what are some common mistakes that are made when going through the process of deploying a DAS? And I will tell you, bar none, the biggest mistake that organizations make is not making an upfront investment in benchmarking their building. So some of that testing that Rick was talking about, finding out what that ambient signal is inside your building is really key because it determines outside of the capacity question, but for around coverage and creating a dominant signal over what's coming in from outdoors so that you aren't ping-ponging back and forth in the signals as Rick described. It's very important to design around a dominant system. What that means is that if you just use some kind of baseline to determine, baseline signal to determine the type of system you'd put in and how dense it is, the cost estimate for doing that could be wildly off. If you've got a little bit stronger signal in some areas, you need a denser system to overcome it. So I've seen many organizations go to RFP and get bids and set their budgets based on standard neg 85 dB of signal strength, which would be in a vacuum would be your optimal signal for voice coverage. And if they were to actually deploy that system in many cases, it just simply won't work. And so that's the biggest mistake that I see people make. I also got a question about if you can estimate the cost per square foot to deploy a DAS and how it varies by type of building. So unfortunately, the answer to this question is a very big it depends. And the biggest determinant of that has to do with your local labor rates. I will tell you in most cases, a multi-carrier DAS is going to land somewhere between $1 to $3 a square foot, 3 being on the really high end where you've got high labor rates, but you can go up from that number depending on the capacity needs that are at a particular site. So deploying in a large football stadium is going to be significantly higher than that because you're dealing with thousands and thousands of people in a very tight space. But your typical corporate office building with reasonable labor rates is probably going to be closer to $1 a square foot. You can also have things when you get into a public safety system. In some places, you're required to create 2 hours of survivability on the system. So you might have to put all the coaxial cable in rigid metal conduit. That's going to drive your cost per square foot up. But generally, in most parts of the country, you're going to land somewhere around $1.50 a square foot for a DAS. But again, you've got a lot of factors that can drive that number north.
Eric, there was one question that came in, I noticed, and it was a question about a tenant and about the responsibility for helping a tenant in a building that's owned by the landlord. Do we have resources? I mean, can we help a tenant have a conversation with a landowner or the landlord about why it would be important for them to install a DAS in that building? Or can a DAS actually be installed just in a certain area of a building if the tenant just wanted to do something on their own? Can you kind of describe that a little bit?
Sure. And actually, I think some of the framework around that question had to do whether new legislation comes out that requires that indoor cell coverage, then who's responsible at that point? Is it the tenant or is it the landlord as well? So that's a great question. So depends on the type of building. If you're in a high-rise building as a tenant, you're going to have a very difficult time deploying a DAS by yourself because the cost of it, you're going to need to use a base station as the signal source. You're not going to be able to take the signal in off the roof. For the same reason that you need a dominant signal, you're going to have a hard time getting the clean signal off the roof of a high-rise building. So a base station is required. Those easily get into a six-figure cost just for that RF source alone. So the cost per square foot of doing that would be cost prohibitive. The carriers themselves aren't going to deploy in that situation either. So no matter what you do, and particularly in a large high-rise building, it's going to be a matter of coordinating with the landlord or building management company or what have you to go through this process. But you as a tenant can be a very loud voice in that process. And when we get engaged with a tenant like that, we may very well ask that tenant to get us an audience with that landlord so we can talk to them about the benefits to their building, the benefits to their tenants, as I had mentioned before, the recruiting and retention issues. That applies to a landlord too. You want to recruit and retain tenants and keep your building highly occupied. In the case of legislation around this, it's a great question. Who's going to be responsible? I would expect probably the building owner in that case, just like they're responsible for putting a sprinkler system in the building, they'd be responsible for what happens in that building. But if you're a tenant in that building and you've got that requirement and the landlord isn't doing anything about it, you might want to take the bull by the horns and take care of that yourself.
Right. Is there another question that came in that might be of interest to the whole group?
Yeah, so there was another question that asked the current percentage split in the U.S. market between the different funding models. So what I'll tell you is that because we're in a transition period, I mentioned early on in the presentation that the wireless industry is going through this transition. It's been a very carrier-dominated world in the past. In terms of dollars spent, I would tell you it's probably 80% of the market is still carrier-dominated. It's a lot less, however, getting done in enterprise space. So in the past, and not too distant past, when we were dealing with coverage and not capacity, that carrier spend was going to enterprise locations to deal with coverage issues for their customers. Today, it's going in large public venues. That's where that spend's going from the carriers, is the large public venues where they're offloading capacity. That's the majority of their spend's happening there. There still is some in the enterprise space. The growing space in all of this, though, is in the enterprise, taking control of that system themselves and deploying their own DAS. But I'd say that's probably 20% of the market today.
Well, we're running out of time. We've been 50 minutes here, and we're a little overdue. I just want to thank Rick and Eric for giving up time out of their busy day to help us as a community to understand a little bit more about cellular coverage inside buildings. I want everybody to know that you can contact your local Graybar office, and we can get you connected with the right resources in order to begin a discussion about how to improve cellular coverage inside that building. We will post to the archive a map of our key locations around the country where you can call in and talk with somebody that can get you connected together with the right resource. We would love to walk through a building with you and have a conversation with you about how we can improve cellular coverage inside your building. The entire presentation will be archived. A PDF copy of this presentation will be archived. That document I was telling you about where the Graybar locations are, that will be archived. All you got to do is go up to graybar.com and look for that G2 Talk webinar logo. Click on this title, and you'll get those documents. Those of you that were one of the first 50, enjoy your cup of coffee. And if any questions that came in that were not answered, those questions will be answered via email. Rick and Eric will handle answering these questions for you over the next, probably the rest of the day and a little bit tomorrow. I want to thank Vision Technologies again for helping us put on this webinar, allowing Rick and the other resources to be made available so that this presentation could take place. I want to thank our marketing department here, Joan and Greg Aranda, for helping on our side to make sure this we had a good event and it could take place today. I wish all of you a great day. Enjoy what's left of it in the upcoming days, and if we can help you in any way with cellular coverage inside commercial buildings, just give us a call. We'll be glad to help you any way we can. Thank you. Have a great day.